Great. Good afternoon, good morning, good evening, everyone, from wherever you're joining us. My name is Peng Zhao. I work at GSOA, at the VP of the Policy and Regulation. Thank you so much for joining us for what promised to be a engaging and forward-looking discussion on the in-space servicing, assembly, and manufacturing, or ISAM. Just want to thank our sponsor for this particular panel, Astroscale, and also the speaker who is joining us. I will introduce them very shortly. So I think for decades, our approach to satellite has been largely launch and leave, right? Designing spacecraft to operate independently for as long as possible, with no expectation of a repair or upgrade. But that paradigm is shifting. Advances in autonomous robotics, rendezvous operation, etc., are pushing us towards a future where satellite can be refueled or repaired or reconfigured or even assembled on orbit. So ISAM technology really holds a promise of extending these satellite lifetimes, a more kind of sustainable space environment as well, and entirely new commercial markets. However, as these kind of major shifts, as with any major shift, it raises some complex questions. So in our today's panel, we will explore three key items. One is about technological readiness. What are the critical timelines and milestones that need to move from ISAM from concept to reality? And what's achievable in the next few years, 5 to 10 years, and what's not? But secondly, we're also going to explore a little bit economic viability on how to build a sustainable business case for this new market. And can ISAM truly kind of compete with a low-cost satellite replacement in an area of kind of mass production and cheap launches? And finally, we about also topics around policy and regulations and also sustainability. So as activity in orbit increases, how do we develop the clear kind of framework and how to encourage kind of responsible behavior? So those are not only technical questions we're going to about today. Many of them are very strategic ones with implication for the whole industry for the future of the space. So with that, I think let's dive into the discussion. I have the great pleasure to have very eminent panelists joining me. They came from different companies sitting at various points of the value chain of the ISAM and can offer a variety of kind of perspectives. So just to introduce them very quickly, we have Andrew Fayola, the Commercial Vice President of Astroscale. We're joined by Mike Curtis Rose, the head of ISAM in satellite application catapults. Jean-Luc Fröhlinger, SVP of Space Systems in Intelsat. And Simon Rose, the head of Science and Technology from Airbus. Welcome, gentlemen, and really looking forward to the discussion. So I think just as a quick start, I would say maybe I give just maybe each of you 2-3 minutes to introduce yourself, especially your company, and what are your role and the activities in the ISAM in this area. So shall we just move with the order of the speakers? Can I start with Andrew, please?
Thanks, Peng, and thanks to GSOA for having me along today. I'm Andrew Fayola. I'm the commercial director at Astroscale UK. We are an in-orbit servicing company. And what does that mean for us? This is everything to do with ISAM, as you described, from servicing at end of life to life extension in GEO and ultimately refurbishment and other kinds of in-orbit servicing activities as the technology continues to develop. But it's really about, as you said earlier, how can we enable operators to work in a safe and secure environment in space, and how can we look at different business models that move us away from a single-use throwaway economy towards a more circular economy in space.
Great. No, thank you, Andrew, for that introduction. We'll come back to you later and also to all the panelists. But just before Mike, I just want to remind people the audience that you have the possibility to ask some question directly to our panelists. Please put that into the Q&A section, not the chat section. Yeah. Mike, over to you.
Thank you, Peng, and thank you also to GSOA for the invitation to participate in this really exciting panel. So I'm head of the in-orbit servicing, assembly and manufacturing team for the satellite application catapult. We're going to use ISAM a lot, and I think it's important just to remind everyone that ISAM, IOSM, and SWOM, and all the other terms all broadly mean the same thing. I lead a team which is developing and operating in-orbit verification and validation, and we have a facility in Westcott, which is near Oxford in the United Kingdom. This is now the largest class of facility in Europe, and it's designed for spacecraft docking and rendezvous validation. My background's in advanced manufacturing and robotics, actually not space, and I've been developing disruptive technology centres across Europe over the last 2 decades. The Catapult is a UK government not-for-profit entity. We're designed to accelerate innovation and the capabilities of space within the UK. We were established about 12 years ago, and we have about 200 people and deep expertise focusing in 3 specific mission areas in beyond Earth, connected and autonomous, and sustainable sustainability for space. Our ISAM capabilities have been developed with partners across the UK Space Agency and industry, and they're designed to explicitly accelerate the ISAM technology across the TRL level, including all aspects: manufacturing, assembly, servicing, repair, and disposal. We've recently conducted some very exciting campaigns with Airbus, Astroscale, NASA, GMV, and many other spacecraft technology companies. And later this summer, we're going to be validating Orbit Fab's in-orbit refueling interface, and also looking at modular spacecraft design for accelerating manufacturing and in-orbit repair and service. So great pleasure to be here. I'm looking forward to a very exciting panel. Thank you.
Thank you, Mike. A very interesting platform of collaboration as well, I think. Let's move on to Jean-Luc, please. Jean-Luc, a few quick introduction about Intelsat and what you do in this area.
Yeah, thank you, Peng. Good afternoon, good morning, everybody. So I'm in charge of space systems at Intelsat. That's everything that deals with space, so satellite design, satellite procurement, satellite manufacturing, launches, and operations. So as you probably know, we're a global satellite operator. We operate more than 70 large geostationary satellites, and we've been an early adopter of life extension services. We actually docked a servicer to one of our commercial satellites 5 years ago to provide life extension. We did another one a year later, so we now have under our belt 9 years of life extension already on 2 of our satellites, and we have several more under contract and in our future planning. So looking forward to the discussion.
Great. No, thanks, Jean-Luc, and thanks for mentioning the past successes already, in fact. So, I mean, when I first touched on the subject, I think people were still thinking about, science fiction. That's something that is coming in a few years, but as you just mentioned, something they are, foray into that area already a few years ago. Let me move to Simon, please. Simon?
Thank you, Peng, and thank you, GSOA, for welcoming me here today. So Simon Rose from Airbus Defence and Space. My role is Head of Technical Strategy and R&D in the UK. So that involves internally with the business looking at where we're focusing our R&D effort and investment, aligning it to the strategy of the business, but also looking externally in the wider ecosystem, so working with partners, academia across the sector. So Airbus Defence and Space, most of you will probably have heard of us. We're the largest space company in Europe. We act all along the space value chain, so satellite manufacturing, but right through to human spaceflight, robotics, ground segment, and also disposal of spacecraft. ISOM is a key area that we're active in. So in the past, we've been heavily involved in the automated transfer vehicles, the ATVs, resupplying the International Space Station, obviously using autonomous docking technology for those. In 2018, the Remove Debris mission was launched, which allowed us to demonstrate a harpoon and also a net mechanism to capture debris, as well as some visual-based navigation technologies. Today, we're actively looking at topics like the Mars sample return. So where we're looking at robotics, how we can return samples from Mars back to Earth, and also looking at specific technology developments like manipulator arms, space qualifying the robotic arm and joints and tools required for the future of manufacturing. So yes, really looking forward to today's panel. Thank you.
Right. No, thanks, Simon. And thanks everyone for this short introduction. I think we can dive a bit more into the three topics I mentioned before. I think the first topic I want to start with is really the technological readiness. I mean, as all of you, as some of you mentioned, there are already different parts that has have seen some kind of proven success already, but there are many kind of technology and innovations in that area. So I just want to ask, maybe starting with Mike, maybe what's kind of innovation in the ISAM technology are currently being developed and to improve the efficiency and success rates of those life extension mission, for example. Mike, you want to start with that?
Yeah, sure. I think one of the most interesting things that we're seeing in terms of technology is the leverage of terrestrial technology into space. And we often see that argument of what can space do for Earth, what can Earth do for space? But we're actually seeing a lot of leverage of technology around autonomy, docking, tracking and identification. We're actually seeing technology pulled from the automotive industry, for example, in terms of using LiDAR, understand where spacecraft are and understand how do we localize them? Because the first challenge isn't so much as docking with a spacecraft. The first challenge is the location of the spacecraft you're intending to dock with, and then the subsequent operation, which Astroscale have the term the dance, which I think is a very eloquent way of describing exactly what happens. So the technology pull through from there is very much then a combination of propulsion, autonomy, identification, and those are some of the key areas that we're really seeing some of those exciting innovations in.
No, thank you, Mike. That's interesting. I don't know if any other speaker have anything to add to that question. I don't know, Airbus, Simon.
Yes, so yeah, I agree with what Mike said there, and I mean, I think there's a few enabling technologies which really need to be mastered for this. So firstly, what we call RPO, so rendezvous and proximity operations. We're obviously working very closely to very expensive assets. So the robustness and reliability of all of the operations in close proximity are absolutely critical. So that relies on navigation, so visual-based navigation, but also more general guidance, navigation and control, so GNC techniques. We have two types of targets in IOSM. The first we term as cooperative. So this is where you have a functional satellite that you have some level of control over and you know what it's doing. But then we also have to consider a much more difficult situation of uncooperative targets where it might be tumbling, there might be no control of it, especially in the debris removal sector, which brings much more challenging situation to deal with. The second technology is capture. So that mechanism, how we capture the spacecraft which requires servicing or refueling. So looking at some sort of docking system or berthing arrangement. So it will be key to master that. And then we get on to the servicing itself, which is really where the robotic arm comes in. So something we're looking at is the space qualification of a robotic arm, including all of its joints, and then the various tools, because there's a number of different situations which will require different tools to grasp or perform certain tasks on the spacecraft being serviced. So yeah, I think there's a number of key building block technologies which need to be mastered, which can then come together for the complete system.
Yeah. Thank you, Simon. I think I did remember a few videos that I saw from Astroscale last year. Where they demonstrated some of those kind of very approach and this how to turn around. I mean, I don't know if Andrew, you want to add anything on that?
Yeah, I mean, I think I'll just sort of concur with what Mike and Simon said, and maybe add a little bit. We look at the need for sort of 4 big areas to work in harmony together, and the guys sort of covered most of them. There is the RPO, the rendezvous proximity operations, and the guidance navigation control software behind that is really the foundation for almost everything we do, right? We couldn't conduct the dance as Mike mentioned without being able to master that. That's how we can operate in close proximity, how we know how to operate in close proximity with other objects, whether cooperative or non-cooperative. There's the robotics piece of it. And we've been working with Airbus, for example, in doing some technology validation with robotic arm in conjunction with the satellite catapults Westcott IOSM yard. So sort of, as you say, sort of tying the ecosystem together there. And then there's the autonomy part of the whole thing. We are operating in a part of, in very close proximity with other objects. Latency matters massively, and these spacecraft have to be able to operate largely autonomously because they can't be controlled directly from the ground when they're in critical operations phases. But then the other final part is that ground segment side, right? We have to have that ability to talk to the spacecraft, understand what's going on, understand what the space situational awareness posture looks like, where it's operating, and that kind of thing. And then how do you have to be able to tie all of those together and be able to ensure that those operations are being carried out in a safe way that's not going to create more debris. And that holds true whether in LEO or in GEO.
No, thanks, Andrew. And I think very important points. And you always think those kind of ISM, happen in space, and it's all about the space segment, etc. But what you mentioned about ground segment and how to coordinate and orchestrate all this, delicate maneuver is very, very important. But I just want to move to Jean-Luc now. I think you mentioned there are some existing, you started to use those capabilities a few years ago already. But I'm just wondering, what are the kind of key, let's say, milestones and that this ISM operator need to demonstrate, and how do we move that into a kind of more commercial, routine kind of service instead of just innovation and a trial type of thing? What's your view on that?
That's a great question. So I think the next step, the enabler of the next business step is going to be in-orbit refueling. I mean, to me, that's key. Right now, the life extension that we're doing on our satellites are using servicers that are docked to our satellites, and that's not a very efficient, economical situation. I call this like the tow truck situation, right? You get a servicer which acts like a tow truck. It remains attached. It can keep the satellite station kept. It can do inclination pull down. It can do satellite relocation. But all the time that the servicer provides service, life extension, that is a captive asset. It cannot do anything else, right? Whereby if you move to in-orbit refueling, now you go from the tow truck concept to a tanker concept, where you have a servicer come in, stays co-located with the satellite, transfer some propellant, whatever the species is required, and then move to the next satellite. And I think that's a more economical situation. And Unfortunately, most of the satellites that are on orbit, if not all, have not been prepared for in-orbit refueling. And so the next step will be to make sure the satellites are prepared before launch to allow in-orbit refueling. That's to me, that's the key next step.
Okay. Now, thanks, Jean-Luc. Any other panelists want to intervene on this?
Sure. I think, yeah. So, I mean, I completely agree with where John Luke's coming from. We need to do this in a series of stage increments. We're not going to suddenly go from 0 to every spacecraft on orbit being able to be serviced, being repaired, being refueled, etc. And there's a whole series of other additional challenges which might change things as well. So, the growth of super launchers, where you just might launch a very big tank of fuel, suddenly might mean that actually in-orbit refueling is maybe less desirable because you already have that fuel on orbit. But at the same time, I think it's going to be a series of incremental stages. So we basically see initial operations in terms of docking and rendezvous. Then we will basically start to see that development of sort of modular spacecraft where we can start swapping out key systems, or maybe jumping to the geo operators in terms of simply going, it's not so much about replacing something, it's actually more important about, for example, looking at a large array which hasn't deployed, or a solar panel which is basically stuck, and addressing those existing challenges, because it's probably easier to fix a spacecraft where something has got stuck than it is to, for example, service a spacecraft where no spacecraft really to date, beyond a few classified missions and the Hubble Space Telescope, are actually designed for service.
No, thanks, Mike, for that. And I think, yeah, so one other slightly different aspect of this technology, then, because and it's more about, you know, the satellite design, I would say. So if those satellites in the future can be repaired or refueled on orbit, I mean, could that lead to operators to take a different kind of design kind of priorities, and maybe slightly more risky kind of design, for example, so knowing that ISAM could buy them out? Like, how do we balance that kind of benefit between ISAM and the need of kind of a responsible space operation? I don't know if anyone like Andrew or Simon, you have any view on that?
So happy to take that one, Ping. I mean, I think ultimately ISOM is just going to increase responsible space operations. I think the benefits far outweigh the risks there. But I do think it will lead to very different mission operation scenarios. For example, obviously today we fuel to 100% at launch because we want to get the maximum lifetime out of a spacecraft. It could open a scenario where maybe we just fuel to 50% to reduce launch costs, and then use smaller launchers, etc. And then if we have that regular refueling in orbit opportunity, the fuel mass at launch isn't so critical. Modularity to allow upgrades. I mean, we could even foresee a situation where we could upgrade complete payloads partway through a mission, or even extend or sell a satellite end of life. We could sort of really open up a second-hand market for spacecraft where it could be a completely different mission, different operator, and have a second life like that. So I think there's lots of benefits to it. There is a risk I could see we should be aware of is operators delaying refueling and repair sort of as long as possible, thinking that if we have these services, it will always be possible to do it at a later date. So there's definitely some regulatory steps needed to make sure that this technology is used responsibly to protect our space and the orbits. But no, ultimately, I think it will contribute to more responsibility.
No,
Yeah.
thanks.
I was just gonna say, I mean, I agree with what Simon said. I think he highlighted a couple of interesting use cases that we are looking at ourselves. There's sort of many other use cases that we think will ultimately make a viable business case in terms of how you look at it. But I also agree that doesn't really necessitate looking at it in a way that's inherently more risky. I think from a regulatory standpoint, though, it is sort of having that willingness to look at, when you think about things like post-mission disposal rates or the way that you calculate availability of a spacecraft? Can you start to incorporate not only internal means but external means as part of the whole calculation? And then you can start to think about some of those use cases that Simon mentioned. How then does that figure into changes in your concept of operations? How does it change the metrics of how you build a return on investment on a particular spacecraft in GEO or across a constellation of many satellites where, statistically, for example, some will fail. But do you build, for the lowest common denominator across the entire constellation, or do you consider augmenting with other types of services? It just the capability that comes, I think, starts to open up a whole different ways of thinking.
No, thanks, Andrew. We'll come back to that, what you just mentioned a bit later on. But just want to see whether Jean-Luc, as operator, whether you have any view on that, whether that may change the way you think about the design of your satellites in the future?
No, like I said, I mean, one thing we're looking at is making sure the satellites that are still on the ground being designed have the right interfaces to allow easy in-orbit servicing. It could be as simple as putting a reflective surface to allow for easier rendezvous and docking, to standard fuel valves that can be easily accessed, to standard USB ports to replace modules. But in terms of risk, we're a commercial company, so service availability to our customer, we guarantee a 99.999% availability. We're not here to take risks, so I don't see that changing.
Okay, good. I think I want to move to a next part, which is more about the kind of economic viability and the more market development aspects. So, I mean, I think that's one thing you already mentioned, Jean-Luc, is to say that if you want to have a satellite being refueled in space, you will have to have those tankers in space, but at the same time, your satellite has to be able to accept those taking fuel in space. So it's really leading a kind of a chicken and egg problem from where I'm sitting. It's like whether service companies need to make a investment first, or whether satellite operator have to adopt and embrace this ISAM kind of technology first. So just want to see whether how the industry can overcome this kind of chicken and egg challenge, and what role should maybe other platform or intergovernmental governments can play in fostering this kind of early adoption. Can I start with Mike?
Sure. I mean, it's a good question. The chicken and egg scenario is one of those really challenging ones for many aspects of space. And usually the best way to overcome this is with some form of government or state-based intervention, either be that on the scale of sort of multinational agencies like the European Space Agency, or whether that's more localized to effectively Canadian, UK, or other space agencies. But really what we need to see are basically the platforms at least helping those platforms be facilitated, touching on Andrew's points and Jean-Luc, in terms of having the ability to do docking and rendezvous. So ensuring that there are spacecraft ideally provided basically either by a consortium or basically by a third party, which doesn't necessarily have a competitive agenda, and use that as basically an orbital test and validation platform. So you might, for example, the UK government, for example, might contract Airbus to build an example geostationary platform, which might have a primary payload, but the payload actually only comes into play later. The main activity is to actually use it basically as a docking platform to allow other spacecraft, other services that might be refueling in terms of topping up hydrogen, or it might be basically swapping out batteries. But we need a series of orbital demonstrators to accelerate it. And of course, there's an element there of combining it with terrestrial facilities as well to ensure that we can practice on the ground. So when we do it in space, we do it right first time.
Great. Any other perspective?
So yes, so I think the way I see, those things developing is key to the success of life extension is going to be the price of the service. And the price of the service directly depends on the price of the servicer and the price of launch of the servicer, right? And this is key. So while, the 2 life extension mission that we have on orbit, we're done with Northrop Grumman, large company, has a lot of depths, both technical as well as financial, had the R&D money to spend. What we see nowadays is a lot of startups. I can name you 12 different startups, most of them in the US, but some of them also in Europe, that are into the life extension business. Some already have contract with us. Some have contract with US government. The US government set up this Defense Innovation Unit, DIU, a few years ago. And that's what they do, is fostering and helping innovation to get faster to commercial services. So if you have a DIU or a DARPA US government contract, and you also have a commercial contract with Intelsat or another large satellite operator, you can easily, well, it's easy said than done, you can raise money because the venture capitalists see the benefit of life extension, and they will give you the money to build your servicer, build your service, and get into business.
Thanks, Jean-Luc. Maybe Andrew, I mean, you're one of those startups. I mean, AstroScale is one of those startups, but I know you have many projects already with established LEO player or with a European Space Agency. But can you talk us through a bit, how this kind of thing has been approached? I mean, this chicken and egg. Do you feel that as well?
Sure. No, I think we're one of the 12 that Jean-Luc's probably looking at across his landscape of things. I was interested to hear how he answered the question before chiming in myself anyway. But I think Mike touched on it as well. The role of government is important here. It's important in terms of establishing the regulatory frameworks under which these types of activities will take place, but it's also in many cases important to be that first customer. We're not necessarily looking for handouts, right? We're looking to help validate the technology that we are developing, and in many cases it's the government customer that's prepared to help foster that environment, and in many cases it's the commercial operator who's actually a bit more cautious, wants to see that it works first before putting money down to do it, and having a first government customer helps to sort of get over that hump, because then you're able to mature that technology. And the next time around, right, there's not as much NRE required. It's a more repeatable process. It means you can make it more economically viable for the commercial environment as well. And to Jean-Luc's point, the most expensive bits are the getting up to orbit and the servicer itself. And in order to get into that sort of commercially repeatable service, whether it's life extension in GEO, end of life services, refurbishment, what have you, right? The key to bringing down the costs overall is going to be sort of doing this again and again and again, and government in the early days can really help make that happen.
Great. So, Simon, anything to add?
No, echo what's been said really, and completely agree with that. I mean, I think there's two difficulties at the minute. I mean, the technology is not quite at the right level of maturity, and the market isn't materialized yet. The commercial market not fully materialized. So I think the governmental and institutional role here is to see this technology through to demo, to give the confidence to the end users to adopt it, and then commercially move it forward.
Great. No, thanks for all your perspective. I see that there are some questions coming in, so thank you to the audience as well to participate. Just picking one question is that I was wondering how might the cost look like between the launching new satellites and refueling existing ones. So I guess, it's more about, because of the decrease of the cost of satellite launches and especially for the LEO constellation, some people can argue that replacing satellites is cheaper than servicing them. So how can ISAM technology demonstrate the economic value? So I'm not sure who want to go first.
Happy to take a shot at that one. I mean, I think there's a few ways we need to consider the value. So obviously, when we look at debris removal, it doesn't create value. It's more about protecting the orbital resource for the future. But life extension and refueling obviously extends the revenue of an existing asset. So I think there's three ways to look at this. So there's the whole investment cycle of an asset. So if it does unlock a second tier market, so for example, being able to sell on a platform at the end of its initial life, there's obviously a second business case to that. But also refueling and performance upgrades potentially increases the return on investment throughout its life. And finally, the in-orbit manufacturing side, which would allow to obviously build things much larger than we could launch in one go. But there will always be a trade-off on cost. But I think the sustainability question goes further than cost, because we have to be in a situation where we protect our orbits. We have a finite number of them. They're obviously coveted for the most desirable ones, and we need to continue to work sustainably. So I think that has an almost larger value than the cash side of this.
Yeah, it's not all about money.
Exactly. Yes.
Anyone else on this question? I don't know, Jean-Luc or
Yeah. So to me, if we're talking life extension, right? Life extension for constellation, LEO or MEO, doesn't make a lot of sense to me. Those constellations have so many satellites. They're usually designed to have, to be robust to a few satellite failure, and extending the life is not the right model, because those constellations are usually designed for 5, 7, 10 years life, and it's important for them to get to the next generation and upgrade their services, right? That's what we see with Starlink V1, V2, V3. That's what we see with OneWeb is going to the next generation. So extending the life of a technology that you want to replace with newer technology doesn't make sense. So I don't see a lot of business for life extension of constellation. Where I see business for life extension is two things: is very large, very expensive geostaged satellite, primarily government satellites, maybe classified satellite, that costs hundreds, sometimes $1 billion. That makes sense. And then for us commercial operator, where we used it is really case by case business, right? So the commercial landscape has changed a lot over the last few years. In the past, customer would come to us, and I'm talking specifically media customers, but it could be true also for network or other business unit. They come to us and they will sign a lease for 15 years, right? Oh, so now ABC or ESPN sign a lease for 15 years. I know I can build a replacement satellite. That I'm going to have the fund to do that. But now those media company, they don't have plans that are 15 years, because the landscape is changing so much with over the top consuming of media. They're going to sign a contract maybe for 3 years, 4 or 5 years. So for us, it makes business sense to extend a satellite for 5 years, which is cheaper than buying a replacement satellite that will last 15 years when you don't know if the customer is still going to be there after 5 years, right?
Yeah, very interesting. I think that, one thing you said is also the difference between the GEO and MEO LEO. I think the kind of the tolerance to the failure is probably a bit greater. But I know, Andrew, your company is working with it's not, let's say, a life extension, but accompanying some of those LEO constellation for the end of life. So how do you see that tension basically?
Yeah, thank you. I agree with Jean-Luc's assessment, certainly between GEO and LEO and where the value points are. It's true, right? The constellation operators in LEO, the entire sort of rationale behind having a proliferated LEO system is that it can handle some certain failures and still be able to provide the bulk of its service. But you then have the issue of, as Simon mentioned earlier, uncooperative spacecraft that can't do collision avoidance maneuvers on their own anymore, that are often not only potentially cluttering up the existing operator who's lost the satellite's orbital planes, but then slowly starting to deorbit through other constellations and in some cases very heavily trafficked orbital shells. So there's an operational cost to doing this. There's a reputational cost to letting this kind of thing happen. And sort of, as I think I said a little bit earlier, when you're speccing a constellation of spacecraft to do a certain thing, recognizing that sort of no matter what you do, right, there will be some percentage of failures. How far do you go in terms of that trade-off of cost per spacecraft across your entire constellation versus, for example, the cost of a small number of removals, right? It does then become that case of, okay, where are my tolerances? Where's the cost benefit? But some of that is, let's say, explicitly dollar denominated, and some of it is reputational as well. And there's value to being a good steward of what is a global commons that people have to take into consideration as well. So the sort of the way you look at these different types of activities and whether it's LEO, GEO, et cetera, are going to make different types of cases depending on the scenario.
Excellent. I was just keeping an eye on the question from the audience. One specific question about return of investments. I mean, do we have any panelists has any kind of a specific figure? The question was, please elaborate on this cost perspective further to actual life units. One standard satellite life versus 5 through 15 years viewer renewal, etc. I think Jean-Luc, you touched upon that a little bit, but do you or any other panelists has anything more specific to offer on the dollar figure or on the year figure? Okay.
So for us, it all depends on the customers that are on the satellite. So the first life extension that we did was with Intelsat 901. The satellite was originally designed to operate for 13 years with a life extension, and the life extension is ending. We're going to undock in the coming weeks. We will have 24 years of life of that satellite, right? So we were able to make the business case work because the price of life extension was good enough to overcome, the revenue from our customers. But this might have been a special case because we were first mover, we're the first to do this. So I wouldn't say that is sustainable long term, but it all depends on how much revenue you're making on the satellites.
Okay. Thanks, Jean-Luc. So before we move to the policy and regulation part, I just see another question maybe related to the previous topic of technology readiness. One question from Rakesh is that, do you think that I guess the ISAM technology will give rise to the standard modular design of spacecraft, and that will enable easy serviceability? I guess I'm not sure whether Mike or anyone has any view on that.
Yeah, I'll be happy to chime in there. Thanks, Payne. Modularity is going to be absolutely key for sustainability for spacecraft, and actually also in space operations in the same way. When you drive a car, you don't drive it to your destination and then dispose of it when the tires basically are worn out. You replace the tires. Now, that's really an easy analogy to do. And when you're talking about a 4 or 5 ton geobus, that's a very different proposition. However, building modularity gives us a whole series of benefits. If we do incorporate modularity, we can start designing for servicing at the outset. Then we can start designing for manufacture, something that many of us in the manufacturing environment are familiar with. And then finally, we can also design demisability as well, but a demisability where we might retire a spacecraft, but we're removing critical components which can be reused in other applications. Simon's already touched on basically, separating effectively the payload from the bus in a way. So, I think it's entirely viable within a decade, maybe less than that we'll see big spacecraft on orbit, which basically are a bus with hosted payloads. And at the end of 1, 2, 5 years, etc., you simply move your payload to a different spacecraft, or your payload is deorbited or recycled, and that spacecraft continues onward doing what it does really well. But the key to that, the success of that, is going to be modularity. And a lot of work needs to be done in terms of interconnects, adaptability, fasteners, etc. When we talk about just simply docking connections, that's one thing. How do we now design things to be removed on orbit without causing mass power disruptions, issues with cryogens, fuels, etc., and so on? Huge opportunities, but modularity is, in my view, the key to the future of the space ecosystem.
Really the building block. Anyone else want to have anything?
Yeah, I think if I could just jump in there. I mean, I agree with Mike. I think there's the modularity piece and the standardization piece, and I think you can do both without losing your differentiation as a manufacturer as well. I mean, again, we always in this industry, certainly in ISAM, I think we always tend to draw lots of examples from the automotive industry, and if you look at someone like the VW Group or something like that, right? They will build a chassis that is then utilized on a number of different models across different brands, and are still able to differentiate those end products. I think it's a similar type of thing here. Doing that kind of, getting to a point where you do that kind of modularity is also going to, I think, raise reliability. It's going to bring down, one of the issues that we have is the costs of doing sort of bespoke platforms, right? If you can start to do more modularity, you could start to bring down those costs, make access to space more equitable ultimately. And on the sort of preparation piece, of course, I will come back to that. And you look again today, any car has a fairly standard spot where you can screw in a towing hook, as it were. That kind of thing needs to come to space as well, because again, it makes it that much easier. You don't need to, as a road services person, you don't need to drive around with a million different ways to try to tow a vehicle away, right? You can do it in a standard way. You can do it relatively quickly. You can do it much less expensively per removal than you can if every single thing is bespoke. So yeah, hopefully we can move in that direction.
Thanks, Andrew. I like the analogy with the car. It makes it much more kind of palpable as a issue. But I think I want to use the last maybe 10 minutes remaining. I think I want to touch a little bit on the third topic I listed earlier, which is more about the policy and regulation, and especially when it comes to sustainability. But first of all, as a kind of startup that's operating in this new area, maybe just continue with you, Andrew. Like, what are the kind of a key regulatory hurdle that you're facing, and you think that the government can should try to help to solve to have a thriving kind of ecosystem for that.
Thanks. There's sort of probably two things I'd want to touch on. One is the fact that there are no national borders in space, so you do have this issue of national regulators that are more or less all doing their own thing, and how you try to get all these different regulators to try to move in the right direction that incentivizes the right behavior, and in a way that there isn't too much divergence that creates an incentive to shop for the least or the most permissive jurisdiction. And then from a sort of regulator by regulator environment, how do you create an environment that has the right incentives? And I don't think anybody on this call or listening to this call wants any kind of over-regulation, but you want to strike that balance where you're creating incentives for the right behavior rather than necessarily using the stick for really strong penalties, so that you can sort of demonstrate, okay, if you behave in the right way, actually we're helping you to save money or potentially make money rather than seeing it only as a cost. And it's trying to get that balance right, which is I think that's why we have experts like you, Peng, to figure out how to get that balance right. But yeah, that's what we look for from a regulatory standpoint. Get that touch right to create the right incentives, and that will be, I believe, a catalyst for innovation rather than a brake on innovation.
Thanks, Andrew. Simon, you want to add anything?
Yes, agree with what Andrew said, and I think this also actually touches on one of the questions in the Q&A about promoting cross-government and international collaboration. I think standards alongside regulation have a really key part to play here, because the market isn't big enough for 3, 4, 5, 6 different solutions to refueling, to grasping spacecraft. So it's really going to be key to have some collaboration around standards, standard interfaces, standard mechanisms for latching on. So I think they go hand in hand to ensure we globally can create a sustainable framework for this.
Yeah. No, thanks. And thanks for picking up the audience question at the same time. Yeah. Great. So moving on. All of you already mentioned that this is kind of this potential to address the debris, through debris removal, life extension, etc. But how do you see the industry's approach, to the long-term operation and space environmental kind of a responsibility? How things will change, or whether that will influence operator decision or service provider decision on how they approach this. I know Andrew, you just share your view on that, but I just want to see whether Mike or Jean-Luc has any further view on this.
So for me, one of the key things, because we do most of our business at the geostationary orbit, is to protect that orbit, right? So I don't want anybody to do a first RPod and a docking at GEO unless it's been demonstrated before at a different regime, because that would be too much risk creating debris at GEO. So that there should be a rule that you cannot do your first docking at GEO. You need to do a demonstration someplace before, and the demonstration has to be close enough to the actual then mission at GEO. So that's the first point. The second point I'd like to mention is insurance. We haven't talked about insurance, but insurance also has a role to play, right? So in-orbit servicing can be used by insurance for repairs, right? It might be cheaper for an insurance underwriter to have an antenna that is stuck being repaired and deployed, or a solar array that is stuck being deployed, rather than paying the claim for a total loss of a satellite. So I think there's some business opportunity there. There's also the servicer have cameras on board, right? So there is, you know, this hungriness to get more views for what's going on in space, and insurance underwriters are also interested to see, okay, you have a claim on this satellite, Viasat antenna didn't deploy. What is the issue, right? Rather than starting a very complex discussion with the satellite operator. So I think we have to get the insurance company in the discussion as well. And the last thing I want to mention, and this is maybe different from any discussion that we had, but this is something that we experienced in the past and we continue to experience is people have to play nice together. And what I mean by that is if I have a satellite in orbit that's providing service that was built by company A, right? And let's just take, because here one of the panelists built satellite Airbus, right? I have a satellite built by Airbus and I'm operating it. And now I'm contracting to extend that satellite life with Astroscale, right? Which is on the panel. And Astroscale is going to dock to my Airbus satellite. They're going to need to have access to some design information from the Airbus satellite. And if Airbus doesn't play nice, meaning they don't provide the technical design information that they have to Andrew and his company, that's going to be an issue. If they're going to ask for a very large sum of money to provide that information, that's also going to be an issue, right? So we're all in this together, and satellite manufacturer and satellite service provider, servicer, have to play nice together.
Yeah. No, excellent point. I think that comes back to the point of modularity as well before, is that, you know, all the components have to have some kind of a standardized way to be accessible as well. So, and that's as much as on the manufacturer side and as servicer side, that they can interoperate somehow. Okay. So I think we almost at the end of this session. Maybe just one, let's say, a slightly kind of a reversed question or more provocative session. Like we do say that ISAM can, you know, can help with the mitigation of the space debris, etc. But at the same time, is there, you know, does that lead to more kind of potential for congestion, orbital congestion, or potential collision? Is a growing, you know, with this kind of all the space usability discussion we had, like how do we balance the benefits of ISAM and the risk of further cluttering the Earth's orbit? I'm not sure who want to take that one. Any?
Yeah, happy to start with that one, Peng. I mean, yes, of course. I mean, any operation induces risks, and that's a given. But I think we have to carefully balance those risks. For example, if we're removing end of life satellites, is the risk of a collision that we are mitigating by removing it, is that greater than the potential risk we're inducing by the removal operation? But I think it comes back to what Jean-Luc said about really being sure that this technology is robust, reliable before we demonstrate it, especially in those most sacred orbits in GEO. GEO isn't an area where we can do demos and should be playing trial and error to see what works. We need to be made sure that the procedures, the teams, the systems are absolutely robust, reliable before we perform the in-space operations.
Yeah, very true. Mike, do you want to, or Andrew, anything to add on that maybe flip side of the ISAM?
Yeah, look, I think ISAM is going to really open up opportunities for more actors in space. But at the same time, I think the growing awareness of the issue of debris, but also the opportunities around servicing, around modularity, refurbishment, this kind of thing, just will, I think, again, a growing awareness, go back to the automotive world, right? When there was very few cars on the road, people drove all over the place. Now, I guess it depends where you are in the world today. People maybe still drive all over the place, but, the rules of the road start to get established as you have more actors coming in and things like that. And so I think, that this is, ISAM activities in general, and we are having to sort of crawl before we walk, before we run. But as these technologies mature and develop, we're opening up opportunities to actually, I think, behave more responsibly in space, not less responsibly.
Good.
And I just add that in a way, this is inevitable. This is not something that we basically choose to do or not do. If we don't do it, others will do it. So there is very much a strategic and an international outlook on this. Every nation, every capability, every consortium, every effectively coalition needs to look at this as this is the technology of the future. It's a bit like saying now electric cars aren't a thing, nobody will ever buy them. We have to look in the same way of modularity in terms of space sustainability. And it's not just to do this for space sustainability. The commercial potential, the opportunity and the ability to grow businesses and create new innovation and create new sovereign capabilities, and at the same time ensure we can continue to operate in space. As Simon says, slots are valuable and there aren't many of them. So if we can contaminate the orbits, that's crazy. So massive opportunity, and it's a matter of what do we do next rather than should we do it at all.
Great. No, thanks for that. And I think, I see that the time is running out, so really just want to bring on to today's discussion. Just want to tell the audience, thank you so much for your participation. We try to answer some of the questions, but any question we didn't have time to answer yet during the live program, we will be addressing them in writing. We did take note of those, and we post that alongside the video on our GSOA website, starting I think tomorrow or the day after. But you can watch the recording of this webinar as well as any previous one on our YouTube channels and at gsoasatellite.com. So really just want to conclude and big thank you to all the panelists for sharing your valuable kind of insight. I certainly learned a lot today. And also to the audience for the questions. So with this, thank you so much and enjoy the rest of your day. Thank you.
Thank you.
And also a big thank you to the sponsor, Astroscale, for enabling this discussion today. Thank you.
Our pleasure. Thank you.